Okay, so now we're going to get into aqueous solutions and the type of reactions that takes place under those conditions in that kind of environment. All right, so most solids, in order for them to react with each other, you have to first put them into a solution first before the reaction can take place. All right. An example of this is the reaction between sodium chloride and silver nitrate. Now, if you take solid sodium chloride and mix it with solid silver nitrate, nothing will happen. No reaction will take place, right? And the reason for that is because in the solid phase, the ions are basically locked into their crystal structure, and therefore they're not mobile, and therefore there's little chance of the ions coming into contact with other potential reactant ions in order for a reaction to take place, right? So if you want to ensure that a reaction takes place between the sodium chloride and the silver nitrate, what you'd have to do is dissolve each of them in water, mix the solutions, and spontaneously and immediately a reaction will take place. Of course, the reaction will be a double displacement reaction, as you can see here, and you're going to have the formation of the solid silver chloride forming, right? The sodium nitrate will still remain in solution as an aqueous ions, all right? So this is typically true for solids when they react with each other. They have to react in a way such that the ions or the particles can come into contact with each other. That cannot be possible in the solid state. You have to dissolve them in the appropriate solvent and watch the reaction takes place. All right? Okay, so let's talk about concentrations of solutions. So when we're talking about the concentration of a solution, we're talking about basically expressing the amount of solute present in a given amount of solute or solvent, or I should say solution or solvent. All right, and we can basically refer to solutions as being dilute or concentrated. These are basically relative terms. You can have one solution being more concentrated than another, or one solution being more dilute than another, right? So those are basically relative terms. But basically a dilute solution will contain a relatively small amount of dissolved solute per given amount of solvent. And of course, a more concentrated solution would have a relatively large amount of solute per given amount of solvent or solution. So for example, one could say that hydrochloric acid is concentrated if you have 12 moles of hydrochloric acid present per liter of solution. And then in some labs, you might have a solution which is more dilute, where you have 6 moles of hydrochloric acid per liter of solution. So, and again, you can have even a lower level of concentration of hydrochloric acid. For example, 4 moles of hydrochloric acid present per liter of solution. So as you can see, whether or not a solution is dilute or concentrated, it's relative, all right? Now, there are different ways of expressing concentration. The first of which we're going to discuss here is what is known as the mass percent solution. And basically, it's very simple. The mass percent is basically the mass of the solute divided by the mass of the solution. The mass of the solute divided by the mass of the solution, of course, multiplied by 100%. So mathematically speaking, this is the way you can express it. You can express it this way, where you have the mass of the solute divided by the mass of the solute plus solvent. But of course, that would be the solution, so you can also express it this way, multiplied by 100%. All right? So, very simple example here. This question is asking for the mass percent of sodium hydroxide in a solution that is made by dissolving 8.00 grams of sodium hydroxide in 50.0 grams of water. So, that's the mass of the solute. That's the mass of the solvent. So all you have to do is plug those values into this equation, and that is what is done here. And when you do your thing on your calculator, you're going to see that the answer is 13.8%. All right, very simple. Okay, here is another example. Now in this case, they gave you the mass of the solution, they gave you the percentage of the solution, and the question is asking what masses of potassium chloride and water are needed to form 250 grams of a 5.00% solution. So remember, the percent expresses the mass of the solute per 100 grams of the solution. But in this case, the mass of the solution is 250 grams. So given that this is the relationship between the mass percent, the grams of solution, and grams of solute, we can rearrange this to get the mass of the solute. So when we do that, we end up with this expression, and all we have to do is plug the numbers in. We have the mass percent here, we have the mass of the solution here. So when we do that, we end up with 12.5 grams of potassium chloride. So that would be the mass of the solute. And therefore the mass of the water would be the difference between the 12.5 and the 250 grams as shown here, and that would be the mass of the water, and that's therefore the answer to the question. So basically, if you want to make a 5% solution, 250 grams of a 5% solution of potassium chloride, basically you're going to mix together 12.5 grams of potassium chloride and 238 grams of water, and that would give you the desired solution. Okay, let's look at another example. In this case, they gave you the percentage of this sulfuric acid solution, and in this case, they gave you something additional. They gave you the density. Now, what this question is asking for is how many grams of sulfuric acid are contained in 1.00 liter of the solution. All right? So the first thing I would do is I would try to determine the mass of the solution itself, right? We can do that because the question gave us the density in grams per mil, and the question gave us the volume in liters. So what I would do is I would first find out what the volume is in milliliters, of course. Milli means 1,000th, so therefore 1,000 milliliters is equal to 1 liter. So we establish that first, and then we take that volume and multiply it by the density to get the mass of the solution. So that's the density. We multiply by the volume, and the result would be the mass of the solution. But remember, the question is not asking for the mass of the solution. The question is asking for the mass of the solute, the sulfuric acid. So in order for us to get that, we take the mass of the solution and we multiply it by the percentage according to this expression right here. So the grams of the sulfuric acid will be equal to the mass of the solution multiplied by the 34% of the sulfuric acid in the solution, and the result would be the mass of the solute, which is in this case equal to 425 grams. Okay, so those are just a few examples involving mass by mass percent concentration. Now, another type of expressing concentration is known as the mass per volume percent. And basically the definition is the mass of solute per 100 ml of solution. So we can express it mathematically this way: grams of solute divided by the mils of solution times 100%. So we can apply that to this particular example here. How do we determine the volume of this solution, which is 3.0%, presumably mass by volume, or mass per volume? So this is the expression, of course. The question is asking for the grams of the solute, so we rearrange it. The question is asking for the volume of the solute, so we rearrange it to solve for that. That's the expression we get, and then we just plug the numbers in. So the volume of the solution in milliliters will be equal to the mass of the solute divided by the percentage, and that's it. Whatever that gives you, that will be the answer, which in this case is equal to 330 mils. All right. Okay, and then you have volume percent, where it's usually applied to solutions made up of two liquids. And the volume percent is basically the volume of a particular solute liquid in 100 mils of solution. Mathematically, you can express it this way. And one thing you need to remember here is that volumes are not necessarily additive. What we mean by that is that if you mix together two liquids, the final volume doesn't necessarily equal to the sum of the volumes of the individual liquids that you mixed, right? So for example, rubbing alcohol is said to consist of 70% of isopropyl alcohol by volume, all right? The ones that are available in stores and so on, all right? You can mix it up by, or make it up, I should say, by adding 70 mils, mixing 70 mils of the alcohol with water to make a total volume of 100 mils, right? Now, that's the correct way of doing it. The incorrect way of doing it is taking 70 mils of the alcohol and adding 30 mils of water. The reason why that's incorrect is because even though 70 plus 30 is equal to 100 mils, that may not necessarily be the case in terms of the final volume of the mixture. You'll find that when you actually measure the final volume of the mixture, it is actually either greater or less than 100 mils. In fact, in the case of isopropyl alcohol mixed with water, the final volume would be less than the sum of the volumes of the two liquids mixed together. Okay, we're going to stop here, and the next type of expression of concentration is molarity. So that's the subject of the next video. Okay, until